Hello, my dear students and the rest of the learners. Welcome to part 24 of a 7-part series of tutorials in computer structured programming in C and Pascal. This is section 3 of 13 in the topic data structures. My name is MemJM, or can simply call me EMELISWAP. In this tutorial, I'm going to look at the data structure by the title Enumerated Lists, under which I'll look on the description of enumerated lists, and then I'm going to see or explain how to implement enumerated lists in Pascal and how to implement enumerated lists in C. Let's commence by looking at the description of enumerated lists. An enumerated list is a user-defined data type in which valid elements of the data are explicitly specified in the definition. An enumerated data type is an ordered list in which each element is given a unique name. The elements are ordered as they are listed in the definition, and all the elements of an enumerated dataset must be specified explicitly. Therefore, we can compare values of an enumerated data type with other values of the same type. This is possible because a comparison between two values is translated into a comparison between the ordinal numbers of the elements. Once the enumerated data type is defined, the compiler assigns an ordinal number in each of the elements of the set in the order in which they appear in the definition, starting with the 0. So, how do we implement enumerated lists in Pascal? An enumerated data type is defined as follows in Pascal. We have the reserved one type, followed by the type name, then equal sign or assignment sign, but not assignment, but equal sign, then parentheses, element 1, element 2, element 3, all the way to the last element, that is element n, whereby type is a reserved word for user-defined data types in Pascal, while type name is the name of the enumerated data type. And then element 1, element 2, etc. are the elements of the set. For example, we can declare a data type called stock or define a data type called stock, and therefore we define it as type stock equals to books, pens, pencils, rubbers. Then a variable of the new data type called stock can be declared if necessary using the following syntax. We have the reserved word var followed by variable name and then the enumerated data type name, which is stock. For example, var stationary of type stock. So in this case, stationary is a memory location or a variable which holds data of type stock. And what is data of type stock? The data of type stock contains 4 elements, that is books, pens, pencils, and rubbers. In this case, the new data type declared can only take one of the elements in its declaration. For example, stock, as we have seen, takes 4 elements, and the variable declared, for example, stationary, can only be assigned one of the 4 values or elements in our definition of stock. Therefore, the scalars in stock are books, pens, pencils, and rubbers. a particular value may be given to the variable. For example, stationery using an assignment statement, such as assign pens to stationery. Adjacent values in the elements of stock can be referred to by using the predecessor and the successor functions as follows. The predecessor of rubbers or pred rubbers would give us pencils as their value, just as you can see from our definition. We have books, pens, pencils, rubbers. So the predecessor of pencils is rubbers. The predecessor of pencils is rubbers. The predecessor of pens is books. The predecessor of pencils is pens. So when we use the word pred, like predecessor for rubbers, will give us pencils. The predecessor of rubbers will give us pencils. When we use suc for successor function, or when we use the successor function suc, it will give us, like successor of books, will give us pens. If you look on this definition, you can see we have books, pens, pencils, and rubbers. So the successor of books will give us pens. The successor of books will give us pens. The possession of a value in the element list is defined by using odd function, where the possession of the first item is conventionally 0. So the odd of pens, or when we pick pens and we send it to the function called odd would return a value of 1. Therefore, because odd of any element returns an integer where x is an element in the list, we can use this expression even in control structures to perform various tasks, because the possession of value, or in other words, the possession of an element within the definition, is defined or is generated using an odd no or an odd value. For example, if we look at the order of our items in our definition, we can see we have books. So books is odd 1. When we look for odd for pens, I repeat, books is odd 0. 0 is the possession of the first value or first element in our list or in our definition. Then pens is 1. So odd pens will generate 1. Then pencils is only 2. Therefore, odd pencils will generate 2. Odd rubbers will generate 3. So books is 0, pens is 1, pencils is 2, rubbers is 3. And therefore, because 0, 1, 2, 3 are integers, then we can use that possession or the possession of each item even in a structure. For example, even in the case as I'll demonstrate just now. One restriction in enumerated or user-defined scalars values is that they may not be transmitted or output using the standard textual input output devices. This problem can be overcome by using a construct such as case number of odd pens. We write out pens. Remember, odd pens. Pen, in this case, is represented using the possession of that element within our definition. Then on books, we'll give or display the message books. On the pencils can be used to write out or display pencils. On rubbers can display rubbers. Then we add. So with this construct, we can be able to output or display the contents or the elements in our definition or in our list, where number must have been declared as an integer. So case number in this case is supposed to be a name of a memory location that owns integer, or in other words, that owns values returned by the odd function, like 0. 0 is assigned in the memory location called number. 1 is assigned in the memory location called number. So case number of all depends is simply means 0 if the number, the value of the memory location called number is 0, return pence. If the memory of, or if the content or memory location called books is 1, then display books. If it is 2, display pencils. If it is 3, display rubbers. Alternatively, an array of strings could be set up with appropriate arguments. For example, assign constant count books into the possession held by books in the definition. So, assign books in stationary index for books or index for books. Assign books into the memory location and the possession for pens. Assign pencils in the memory location called stationary but at the possession for pencils. Assign rubbers in the memory called stationary but possession for rubbers. Therefore, stationary books is simply like saying stationary subscript 0. It assigned into 8 books. Then assign books into the possession or subscript that is occupied by pens. This statement can also replace, this statement here can replace the element pens with books. Do the same for pencils and rubbers. So assign rubbers into the memory location called stationary, but at the subscript for rubbers. In this case, the following write statement could be used to output the name of the item. Write stationary, or in other words, pick the content or memory location called stationary at subscript for the item. But the variable item must have been declared as a counter of type integer. Enumerated data types can be used as subscripts in an array. For example, an array for storing stock would be declared as var stationary array of books to rubbers of integer. So in this case, books to rubbers is like the indices. It's like saying var stationary array subscript 0 to 3 of integer. Array subscript 0 to 3 of integer. My dear students and the rest of the learners, don't forget that we have said to be able to get the position held by elements in the definition, we use the function odd. And therefore, when we write this declaration statement as var stationary array or type array spanning from index for books to index for hours of integer, we are simply like saying it is var stationary, memory location called stationary of type array whose subscript is books to hours 0 to 3 of integer. Since the subscripts range, including all the values in the defined type, this could have been written as var stationary array stock of integer. Remember, stock is already undeclared user-defined type. And therefore, we can replace books to hours or that range of subscript with the name stock. And therefore, var stationary array stock of integer. But we know what stock is. Stock represents books to hours. So 0 to 3 of integer. The elements in the enumerated list can be set to a certain value. For example, 0 using this statement. For item, books to hours do. In other words, for books assigned to item or the memory location or the possession of books assigned to item to the possession for hours do. Remember, in this case, when we use the word books and hours, we are simply referring to the order in which these elements are listed in our definition for stock, or in our definition that we have already defined. And therefore, we can use the ones books and even hours as our range for counter or for counting. So this can simply mean that for item 0, 2, 3, do. So stationary item assign 0, or 0 we assign to the memory location called stationary at the possession for the item. The Boolean data type is also an enumerated data type, which is predefined in the language, and its elements are true and false. Since the subscript range includes all the values in the defined type, this could also have been written as follows: var stationary array stock of integer. I have already said what that means. So the elements in the enumerated list can be set to a certain value, just as I have said, using, for example, 0. So e.g., 0 using this statement for item equals to books to hours do. And we have seen how we do that. We assign 0 to that possession. The Boolean data type is also an enumerated data type, which is predefined in the language, and its elements are true and false, just as I have said. Therefore, the following is a Pascal program implementing enumerated list, whereby it requests the user for a product code, and then it displays the name of that product and its price. So that's our comment. My program is called good sales. Then I have enumerated list declared or defined as type stock equals to books, pens, pencils, rubbers. So this is a definition of a data type called stock, which is user-defined, and its elements are books, pens, pencils, and rubbers, just as you have seen in my explanation. And then the variable that is going to be holding the possessions of the elements is number. So number is of type integer. Then I have another variable called stationary, which is of type stock. And we know what type stock, data type stock contains. It contains books, pens, pencils, and rubbers in that order. Then we have begin. So we display the statement, enter the product code number, and the user types a number, which is then stored in memory location called number. And then we are able to use that value in memory location called number to display the item that whose number is entered, and of course, its price. So case number. So if you enter the 0, it will be case 0 of. Then find out which of these functions returns 0. If odd books, meaning books, is 0, then display the message, these are books, and the price for the book is Kenya shillings 30. However, if the value entered when passed to, or if the value entered is the same as the possession, or the value returned by the function or the pence, then display the message, these are pence. Price for a pen is Kenya shillings 10. If the value entered is the same as the value returned by function or pencils, display the message, these are pencils, and the price for a pencil is Kenya shillings 5. If the value entered is the same or equal to the function or the value returned by the function on rubbers, then display the message, these are rubbers. The price for rubber is Kenya shillings 20. Otherwise, if the product code number entered does not match, either on the books, on the pens, on the pencils, or on rubbers, display the message, this product is out of stock, because that element is not found in our definition for our data type stock. And we end the case. And then we pause on the screen. We read an empty line. That means we pause, or the program will pause to allow the reader to read the output, and the program ends. How do we implement enumerated list in C? An enumeration is introduced by the keyword enum, and it's a set of integer enumeration constants that are represented by identifiers. The values in an enum starts with a 0 unless specified otherwise, and are incremented by 1. And therefore, my dear students and the rest of the learners, in C, we don't have the reserved word type, but we replace type with enum. An example of enumeration is just like the examples I've shown you. The only difference is the syntax. So in this case, we have enum stock, and then under stock, we list the elements, books, pens, pencils, rubbers. So that is the definition of our data type called stock. Instead of letting the compiler assign the ordinal values automatically to the elements of the new data type stock from 0, you can set explicitly each enumeration constant to each identifier or element in the list by assigning a value to each identifier. In other words, you can change the default by deciding yourself what value is to represent which element in the data or in the new data type. For example, we can have enum stock, then books. We decide how many items are in books, or the value for that element. So like in this case, we assign 10 to books. The rest, pens, pencils, and rubbers remain. And therefore, instead of books being or turning on no value 0, it is going to hold 10. In this case, the first element has been explicitly set to 10. The remaining values are incremented by 1, resulting in the values 10 through 13. So if you want to initialize the first element within the list, you assign into 8 a certain value, and the rest of the elements will be 1 position ahead based on their order. For example, pens will be 11, pencils will be 12, rubbers will be 13. Instead of books being 0, pens being 1, pencils 2, and rubbers 3. So anytime you want to change the starting value of the list of your items in the defined data type, you should always initialize or assign a value to the first item or element in the list, and the rest, their possessions will just be an incrementation of 1 from the previous. Similarly, each of the elements can be assigned its own constant value. For example, enum stock books equals to 10. So assign 10 to books, 28 to pens, 5 to pencils, 11 to rubbers. So, my dear students and the rest of the learners, note, if you assign the first value to the first element, if you assign a value to the first element, for example, 10 to books, and you don't assign anything to pens, pencils, and rubbers, we have said that that value, or the value that will be represented by pens, by pencils and rubbers, will be an increment of 1 from the previous element. But if you want to change that, then you need to assign a certain value to each of the elements. For example, 10 to books, 28 to pens, 5 to pencils, 11 to rubbers. And that makes much meaning, because if you are, for example, stock, various products will have or will be of different numbers. You have different amount of books, different amount of pens, different amount for pencils, different amounts for rubbers. Also, multiple members of an enumeration can have the same constant value. In other words, you can have all the elements having a constant value. 10 books, 10 pencils, 10 rubbers, etc. So a variable for the enumerated list, for example, quantity stationery, can be declared as enum stock stationery. The following is a program implementing enumerated lists in C to display the names of the months in the year. So we have our comment. We include the standard header file or standard input-output header file, because we are going to make use of the input and output functions in our program. Then enum months. Then what is the composition of our data type? January, we assign 1. So that simply means February will be 2, March will be 3, April will be 4, etc. up to December. So those are the elements in our data type called months. Then our main function is here, and then we declare a variable for manipulating the contents of our enumerated list. And in this case, it is month. So enum months, month. Simply it means that month is a variable for the data type, user-defined data type called months. So we then initialize months using a pointer. I'm going to discuss about pointers in my subsequent presentations, and a pointer as data structure, but this simply means that we are going to refer or assign the following items in the memory location pointed to by the pointer month name. So we initialize months using a pointer. In other words, we are assigning our elements, the following elements, in our data type called months, but through a pointer. And our pointer is called month name. So we are assigning into it the following constants for the months or the names of the months: January, February, March, April, May, June, July, August, September, October, November, December. Then we display the months of the year in their order as follows. For month equals January. In other words, we initialize month with the value, with the ordinal value, with the ORD value for Jan. Then we check if the value is less than or equals to the value represented by DEC. Then we increment by 1. In other words, this is how this function will work, or this control structure will work. Remember, to understand how the for structure works, kindly go through the presentations, my earlier presentations on control structures, and especially on the iterative control structures presentation. So check whether or initialize month with the value for January, the position value for January. If, or in other words, display the name of the month. Display the name of the month. So simply, this statement means that because we want to display all the months of the year, what will happen is, or this statement means, initialize month with 0, then display the content of, or let me interpret it in a simplified manner. So first, initialize month with the first value for Jan in the element. For example, if it is 1, then, and of course from the definition, we can see in a month, Jan is 1. So pick 1, assign it to memory location called month. Then check if that value is less than or equals to the value for December, which is 12. So if Jan, if 1 is less than or equals to DEC, in this case 12, then display the content of the memory location called month, followed by the month name, the content of month name at that position. So our first position is 1. So this statement will display 1 followed by the name of that month. So it will display 1 January. Then increment the content of month with 1. So initially it is 1. So incremented by 1, it becomes 2. Then check, is 2 less than or equals to 12? Yes. So display number 2, or display the content of month, which is 2, and the name of that month, February. Once that is done, increment the content of memory location recording month again with 1. So 2 plus 1 becomes 3. Check if the content of memory location recording month is less than or equals to DEC, that is 12. It is true. Therefore, display 3 followed by the month name represented by that position in our list, which is March. And that will continue up to December, that is 12. Then check. If the content of month, memory location code month is 12, check. Is the content of memory location code month less than or equals to 12? So is 12 less than or equals to 12? Is content of month 12 less than or equals to 12? So once, or in other words, that will continue until when the content of month will not be less than or equals to 12, and then the program will end. In other words, the return 0 will turn the control back to the operating system, and our program will end. And therefore, the purpose of this program is to display the months of the year spanning from January, position 1, to December, which is position 2 in our enumerated list. And with that, my dear students and the rest of the learners, we have come to the end of section 3 of 13 in this topic on data structures. You can now proceed to section 4 of 13 in this topic in the next part series of this presentation so that you can learn more about the next data structure. Congratulations for learning section 3 of 13 in the topic data structures. You can also access section 1 to 13 of this topic, other topics in the computer structure programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence or comments, kindly write it to us through the email emeliswap@gmail.com. Thank you very much. Let's meet in the next part of this series. God bless.